Thank you all for joining me in this morning's session on managing FMX views. We may get some more people to come in. I know it's always tough to get going after a nice break and we get started. And of course, we have another session, then lunch, and then I get to speak to you all over again a little later this afternoon. But this is I may go a little bit long, just I'll warn you that right now, but I'll try to finish up as much as I can on time. There's a lot of material to cover in this topic. To start, how many of you have actually worked with FireMonkey or FMX? Okay, so about half or so. That's pretty typical. Some people are still, it's been around for quite a while now, and the early days, FMX was quite a bit of a challenge, and then it was all trying to get us to be cross-platform. But with that, brought a whole bunch of new challenges that as VCL Delphi desktop developers, we never really had to worry about. One of them was this concept of a view and the fact that we are running on different form factors. Mostly, the reason why we wanted to get there in the first place was to get to the phone. Can we have our Delphi apps running on an iOS device or an Android device? And then just by extension, we have all these other frameworks that we can target in our platforms. So Mac OS and Android, Linux even to some extent. So what I'm going to talk about is this idea of a view. What does it mean? How is it different than a form? How does that impact the way we manage and construct our applications? Because if you follow along and you open up the sample apps and the templates that are in the code repository and that you can download through the Get It package manager, and they all kind of tackle the problem in a very similar way. And it's great for a very simple demo app, but as you soon find out is once you start doing something a little bit more real, you run into all these roadblocks, these walls, and it's like, oh my gosh, I can't believe this is the way. Well, I'm here to show a new way of tackling this problem. So moving on to what does view management mean? And it's easiest when you think about it in terms of your phones. But it doesn't necessarily have to be that way. But the phones, we typically run one application at a time. And I'm not talking iPads or tablet devices where you can do multi apps and so forth. Same principle though. But we have sections of our app. Generally, we like to call it a screen. And we navigate. Open up any application. We have one screen that we're working on. We want to navigate to the next screen. Very wizard-like. There is a stack, a navigation stack that our apps usually follow. So it's just not haphazard. We're walking through. We kind of back up. We go down another path. We might pop up to a settings that might always be available. So we want to get to that and be coming back to where we were in our place in our applications. One of the things to understand right off the bat is we are not talking about form management. VCL side, same is true in FMX because it's all based on forms, but this is a different notion. In VCL Windows applications, we have a true dialogue, modal states that we work in and operate in. You generally don't have that in the mobile world. It's actually modal concepts. You can mimic it, you can fake it, but the OSs do not like it. And so this is where we're drawing that. Well, the key thing is as you add more views, the complexity grows exponentially. All of your input patterns, all of the test cases, the way you get to a certain point, they all get more complicated. And that's just from the getting it to work. Now we start talking about, well, if I have multiple developers working on it and all these other challenges that come into play. So fortunately, FMX comes with a pretty cool, rich control that helps us do most of what we want. The mechanics of switching a view is typically handled by the tab control. Does it need to be? No. Why is the tab control so popular for doing FMX view management? It's because it's got built-in animation. And by default, the slide animation that we're used to seeing. So if we tap a button on a list and we want to go to a details page, we expect the slide to the next view to come into place. You don't want to write that yourself. Why? Just have the framework do it. Well, that's exactly what the tab control gives us. We're not really making a tabbed interface. It's just we have a container that knows how to animate to the next container. You could certainly do that yourself, and you may want to if you want to have different animation techniques to slide in. Maybe you want to pop up from the bottom. TTabControl doesn't do that. It just does the sliding left and right. So you get my point. So it's visually effective, I described, but there's some challenges when it comes to implementing any non-trivial application with the TTabControl. And so let's take a look at some various ways we tackle this problem. Well, the first is we use the TTabControl as our foundation. We have our main form, we drop a TTabControl on it, we create a new tab, hide the tabs because we don't want physical tabs showing up, so they're hidden, and we create one for each view that we want to navigate to. Great. There's the idea of an active view, whichever tab is up front, and then we can navigate back and forth between that. Okay, great. Everything's on the form, so now you have separate tab controls, tab sheets. You go in and you put all your controls down, then you switch over and you put all the controls down on the next view, and then of course you're writing event handlers for each of the controls on that view, which really are different than the event handlers on the first view, but they're in the same DFM file, or FMX file, because it's FMX. So it's a big form file that now has every single control of your entire application in one form. And you know how Delphi just loves to put new event handlers where? At the bottom of the file. That's probably 99.9% of the time not where you want that to go. So you're constantly rearranging the code or coming up with some method in which you can organize this massive file that represents your application. Terrible. So I think I just nailed all these. It's cumbersome to work with. It's very difficult if you have multiple developers. If you have a non-trivial app, you might not be doing everything yourself. You may want to farm out different views to different developers. It's one file. So be sure you do your repository commits cleanly so you don't get to merge hell. So we've got that. Option number 2, and this is quite common, and it's the one that's promoted in some of the sample apps that you can download from Embarcadero. And this leverages the TTabControl still because it's the mechanics of navigating, sliding forms. Instead of using single control, you create a frame for each of your views, and then you create an inline instance of that frame on each TTabControl. So the idea for this is that, I've got each view in its own frame, which is a separate file, so I can work with that and manage it, but I'm assembling them all together on the main form with each one. Now, sounds kind of cool, but there's, of course, challenges with this option, otherwise I wouldn't have this session. And so the issue that you have really is kind of tied to the fact that we're using a frame. So first off, it's still kind of cumbersome, and that to use and to manipulate. Really because you are creating this inline instance on the main form of your TTabControl, which is a live, fully functional user representation of that frame. So much so that if you make changes in the inline instance, you've made changes that are disconnected from the underlying frame control. So you have to be very diligent to make your modifications only in the one spot so that they get propagated to the right spot in your inline instance. You can also very easily double-click on a button in the inline instance and create an event handler inside of your main form, which is probably not where you want to create it. So you can do it, but it's cumbersome. It's like you have to be careful. One of the things that bugs me about the frames is that if we're going down this road, we're probably doing multi-platform to begin with. We want to target multiple frameworks, Android and iOS being the most common. Throw Mac OS in there as well. What does it look like if we are picking up that platform? So we want to be able to look in the IDE and style it to, look like an iOS app. Does everything look the way I expect it to? Change it to be an Android app because button sizes are different. Tab control orientations, if you have actually a tab control inside of your view, you want it to be in the right spot. So being able to switch between the style representation is important. You can't do that with a frame. The combo boxes are gone when you were designing a frame. So all of these challenges kind of led me down to this road of, well, can we do something better? And fortunately, I can say yes, although there's a little work involved, and it's what my session's all about. It's how did I get to this end state and where we're going to show. So high level, we're still going to leverage the tab control for the mechanics of sliding. It works, no sense to worry about it. But instead of creating a frame, we're going to create a separate form, which we do all the time. We know how to do that, really simple, nothing new, nothing you have to install. So we're going to create a new form, design our views on that form inside of a layout control. And the layout, which is the container, is going to help us kind of move things around when we need them. So we're going to leverage that. We're going to use interfaces in order to, a true, like view form, for example, is an interface we're going to use to drive all of the commonality that we would have in our applications. This idea of a navigation stack, being able to switch views and go backwards and understand, well, what are the views of my application? And be able to manage that and have that code be able to be shared across multiple applications. But the cool thing is because we have each of these views in their own form file, you get the full designer surface of Delphi. So all the style changes, you can do all the layout techniques. You don't have to worry about an inline instance being created and being tweaked outside of your code. You can easily have multiple developers working on different forms for the project. And the main form simply assembles them and instantiates them and moves on. So we're going to dive into each of these. But before I do that, I actually want to show the end result first. And then we're going to look at kind of the pieces that made it happen and how we can extend it and do more if we wanted to add new views and things like that. So if you were in my session yesterday, you know I'm a big Major League Baseball fan in the US. I know that's not super huge over here, but there's lots of rich data, and I'm leveraging the same type of data I was showing yesterday in a new app. And so this is called Cubs Stats. Cubs is the Chicago Cubs. I'm from Chicago, my favorite team. Been a diehard Cub fan since I was a wee little lad. So what this app does, let me go ahead and run it. Now I'm targeting Windows 32 only for this to do it quickly. It is cross-platform. You can run this on an Android device or iOS device. That's why the form factor looks the way it does. So what this does when I fire this up is it kind of has that same size, and it's gone out and made a REST call to grab the roster for, I guess that's what I last had it as, 2011 season for the Chicago Cubs. And so I can click, and we saw a transition. There was a startup saying, I'm getting everything loaded. Now I'm ready to go, and here's data. So I'm already on my second screen. This is the roster screen. And I can click on this, go and retrieve the photo, the new roster. I get the list. I can click on a player, and now I drill in a new view. And this gives me details. Now it happens to be if he's a position player, I get hitting statistics. If I go back and find a pitcher, which is what the P stands for, and click on that, I retrieve the pitching statistics. Pitchers don't hit anymore, and blah, 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 blah. Not going to worry about it. I should probably do this for football, and you guys would all be excited about that. So anyway, this is the app, and it works quite well. I can have a pop-up where I click on the hamburger icon, a little slide-in comes in. The slide-in is a multi-view component that is built into FMX. I don't really care about it. It's this, hey, give me the slide component, so I know that's something my host probably wants to have, is some way to have a side panel. So the framework that I'm showing supports that. I click on a settings panel. Well, here's another screen, another view that I'm going to manipulate, and I can change a startup logo and go back to my main form. So that is the app. So fully REST service call. The REST calls are done in the background thread. There's a lot that's in there. You get the full source code and the download material for the whole app. So you can drill in as deep as you want. I'm focused on this session on managing these screens. What do we need to do for that? And so let me switch back over to the slides to give the high-level view of the design, and then we'll drill back into the code to see where it's been put together. Okay, so biggest question we all want to know is, how is this working? And well, actually, before I do that, let me switch back over to here and just show real quick that my main form, this is the main form. It has little pop-ups that show up. They're there. Here's the slide panel. The tab control is sitting behind it, and there's nothing in any of these tabs. They're empty. And so the settings view form is a form. And so I get, here's the roster view, and I get all the style options and so forth. I recommend creating a layout control and put everything inside that layout. And then the layout is going to be important when we get a little further along, but this is just a line client to the form. So the form in this case is really just a design surface for us to work with. The layout has the real content with the view, but in addition, it also has any event handlers and things that need to happen are in that form unit. So I'm now separating my view implementation details from my main form or my host. The host is simply going to orchestrate all of the communication. All right, that was just a little bit more context. I think it'll be helpful as we talk about what do we need to do. Well, the key concept is we have this idea of a view. And so if we can make that more formal, something that's more concrete that will help us manage it, that's going to be really powerful for us. And I do that by creating an enum. And so it doesn't have to be fancy. It's just an enum that says, here's my set of views that I want to be managing. So it allows us to do navigation. We have an implied order that we would want our views. Like we should know that like, oh, when I'm done with the settings view, we always go back to whatever that other view was. Or my roster view has to come out first before I go to hitting statistics. So the structure makes sense. And of course, the challenge that we have with all of this is I didn't want to just do this for this application and have to redo all of it for another application. But the challenge is that these views are very application specific. Your application's probably not going to have a roster of baseball players. So I didn't want to come up with some generic thing like, content list and content details list. It's like, no, we have to code it to make it specific. So the real challenge in doing all of this is, well, how do we generalize this in a way to where all of the things that we constantly do for each of our applications, the management of the views, being able to go back in the navigation stack or, tell it to go and display an activity window that, hey, I'm doing something. Every app's going to have that. Why should I be coding that new? But it's complicated because I have app-specific things that those functions need to know about. So how do we get that to work? So really, the goal or the key of the whole thing is to leverage not only generics. How many of you guys use generics? Generic types, collections, so forth, great. How many of you used interfaces? Interface, a few of you, a little less. Yeah, okay, great, go ahead. So to make this work, we take both of those concepts and slam them together. And we use generic interfaces. And it might blow your mind a little bit because I'm going to walk you through how it's connected, but it's really powerful. And you can certainly apply the same technique to other code, even if you're not doing, FMX views. But it really helped make this all work. So we have a unit. It's a very simple unit that does the logic of what it means to manage it. We can take that over and use it in all of our applications. And we have another unit that is the app-specific versions that's related to the first ones, and we just kind of set it all up. So let me move forward. And did I skip through? Yeah, goodness gracious. Double click there. So this is the common unit that we're going to use for any of our applications that want to manage these views in this way. And so it defines some interfaces that the first one is that it defines what does it mean to be a host, a view host. And that is your main form. And a view host is going to have certain functions that it needs to perform. So, the purpose of an interface is to declare that contract. If you want to be a host of these views, you need to implement these methods. And so we're going to have that. So by in and of itself, it's not a big deal. So we have this iForm view host, and then we also have the iForm view, which is an interface, but it's a generic interface. And it takes the TV, the T view, that's the enum that we're going to talk to a little bit, and it also takes another interface reference to a view host. So we're basically taking another layer of indirection to make this work. And so it didn't dawn on me that we could actually do that. And I didn't think the compiler was going to like it. And I was very pleasantly surprised when I played around with it, like, oh, it is figuring it out. It does know how to resolve itself at compile time so that we can do this generically, which makes sense because that's what generics do. Generics say the logic that I want to do is the same. I just don't necessarily know the type of data that I'm working with until later, and when I create a concrete instance of that generic type. Well, that's what we're going to do. We're ultimately going to have to create a concrete type. We're just building interfaces. That was what we're using for our application. So our interface is actually creating a concrete type using another interface in order to do it, which sounds a little odd when you first say it out loud. And so the final piece that the form view types unit gives us is a base implementation of iForm view called tBaseFormView. And so that's shared common code. Our application interfaces are going to descend from this eventually. So that's the next step. So that's where the real work does. So digging in a little bit deeper, this iForm view host. What does it mean to be a host? Well, we're going to do certain things like, well, we should know how to go back. So whatever screen we're on, whatever view, what does it mean to go back? So we're going to implement some hierarchy or navigation stack, showing a sidebar. Now, your app may not have a sidebar, so that implementation of that's going to do nothing. No big deal. Common things that we would want, we're going to want to edit settings or change the settings. What do we need to do that? The interface says, yes, we can support that. What actually does when you make those changes is in your code. Same thing with showing an activity panel. What does that mean? For my app, I'm displaying the little green pop-up that says I'm retrieving statistics. You might do something completely different. If it's more of a window, like a desktop app for Mac or even Windows, you could put a status bar telling you what that is doing. Same thing with errors. Error panels, if there's a problem, I can't get to the service, what do you want to do? So the iForm view generic template here, so it defines the core features of a view. Really, the role of this is to form the conduit between the form acting as a view, the thing that we're creating, and the view host. So the view host is going to be manipulating our views. Basically, hey, you're now to come up front, so I need to know about you. I need to be able to do things to do that. Well, and likewise, the view itself, if I'm doing something, meaning the view, I'm clicking a button to change it, I'm going to want to tell the host about that because it might require me to go to a new view. And all the navigation is managed at the host level. So we really try to make that view be very isolated. It's like how we're supposed to design our units or our methods, just do one little thing and nothing more. That's the principle for this. So that's why we have to have references to, okay, where's the view host? What's the view, that I'm working, that this thing is defined for? And again, I don't know what enum type my views are going to be until the project tells me. So generically, we can work with any type that's going to be used as a view and the rest of the function. So when I leave or enter the screen, we may want to do things. If we go into the view for the first time, we may want to rearrange the controls based on data that we've loaded in the previous step, which is what happens in the app here. Likewise, if I'm leaving it, maybe I need to auto-save or auto-clear, for example, a login screen. I've logged in to my credentials. I've made the web service call to validate. I'm moving on to the next screen. On the leave of that screen, you probably want to clear the password. So if they go back, it's gone. It's like we don't keep it there. So things like that, we want to know about those notifications. So the implementation of this is a base implementation. So notice how tBaseForm, it is a T, so it's a type, a concrete type. Well, it's a generic type. It's not an interface because I still have template parameters. But notice how they simply get passed to the iForm view which is saying T-base form view, TVIVH, is descending from T form, it's a regular form, but it's going to implement this interface of iForm view with these parameters, and then we just write out the same thing we just showed. So the interface we just looked at, here's the implementations of those, although it's really just a generic implementation for the moment. Once we do something with T-base form view is when we're going to finally fill in all these templated parameters to create something real. So now we move on to the application specific things. So that one unit can go any projects that you want. Now we start looking at the application specifics, and there's only a few things that you really need to do, which is really quite cool. So the first is we need to define what is TView, that enum, project specific. So we're going to show that in just a moment. We need to define our app specific view host, because there's things that the host may want to do that are app specific. There's general things, but from a host point of view, remember, we have views that are going to talk to the host to let them know we want to do things. It's probably beyond just the basics. So this gives us an opportunity to share additional host functionality with all of the views that we're going to create. And then there's some helpful implementations, concrete types now, that we're going to use to do all of the work. So let's look at each one in specifics. So key feature here is the view. It's just a basic enum. So these are the different views that I have. I showed all of these. So we have startup, that's what popped up, settings roster, hitting stats, and pitching stats that we've got. So very simple. Now again, really complicated app, you might have a lot of views. And I would generally structure them in the order that kind of follows with the navigation stack as best it can. You're going to have jumps, and this view might actually lead to 2 different branches. So just organize it to whatever makes sense. The iView host descends from the iForm view host. Remember, I say remember, but it was 4 slides ago, and I've forgotten whatever it was. The iForm view host is the shared one. That defines what a host is minimally supposed to support. We're going to say, but our application is going to add some additional things that our host needs to provide. First and foremost is this app data, this idea that we're loading in data, statistics from a roster, from a team, and for a given season, we want to store that. We're going to be able to need to use that throughout of our different pages. So we can have an app data that holds that for us, and the host will hold it for all of our views. And then when it comes to selecting a season's roster, so when I navigate the arrows to change what year, well, I don't want that view to be the one that makes the REST service call to go try to retrieve those, because it doesn't have all of the things that it needs to do that. I don't want to duplicate the REST client components on every form that's making a REST call. The design that I'm using is I have one set of components. It's on the main form because the main form has the activity indicator and whatever else I want to do. So this allows a view to say, hey, I need a new roster. The host gets notified because of the method call and performs it on behalf of that view and updates the data, and then we'll tell the view, hey, I've got new data for you, re-update your display. So this is why we would want app-specific host functionality. T-form view, this is like the second key. The first key being set up enums for your views. Here is the concrete implementation, finally. We've had all these interfaces with kind of, this is how we want it to work. Here is what we're saying. Our T-base form view, the generic type we created in the shared one, is now being concretely implemented using our app-specific enum type, TView, with the interface we just showed that has our app-specific host functionalities. So we've defined that. So a form view, new base class, is got everything we need. It does the connections between everything. And so any forms that we create that will be a view simply descend from tForm view and implements anything that might need to be implemented for that interface. And then the final piece that's in this shared unit, pretty straightforward, is simply an alias for an array type of enum. So tview is our enum, so it's an array of enum, indexed by enums, of a tForm view, which we just defined, is being, here is the real definition of a form view. So this array type simply is, we're going to create an instance of this array inside of our host, the main form, so that it knows, oh, I've got all of these. What is the form that represents, the settings view? Well, it just goes to the array that holds it, and it knows it. Okay, a few more slides, and we'll look at the code, and we'll get some questions. I'm sure there's a lot that's here trying to assemble it. I'm trying to kind of categorize where the thinking is. So from the main form, basically our host is going to implement the iView host, which, because iView host descends from iForm view host, it has to implement all of the features that are there. We show those methods. We'll take a look in the code. And then the key things, what I'm highlighting here is in the definition, in the private section, you need to create some fields and two methods. So we need the views, which is the array. So this is where the alias comes in. Then we're going to have, well, what is our current view? And so we want that as a separate reference to hold what is the thing we are currently working with. And that's going to be helpful for the implementation details that we get in moving things around. Populate views is where the real work happens, where we take all of these forms that we've created with the layout contents in them, and we want those to now go somewhere. Well, in pages of our tab control, or different sections. It doesn't have to be separate tabs. It's just a convenience. The framework allows you to put any container to host a view. So you could go side-by-side views or have a grid view and each one populates it. You could create multiple instances of the same view and have them presented in your UI if you wanted. And then the change view is really what does some of the coordination of like, oh, I want to change to a new view. What needs to happen? It's pretty straightforward. Populate views looks a lot more complicated than it is. It's pretty straightforward because what happens is, if you've ever dynamically created a form before, this is all that is. I'm creating the startup view, giving it application, so the application is the owner of that form. So startup view is a form, I create that, and I take that reference and store it in my array. So my array is indexed by the view enum, and so I'm holding that form. The init view is a method that I need to implement, and it takes the view enum, because each view should probably know which enum is connected to it, so it's just helpful to know that. And then who's going to own it, and then the self represents the host. Who is going to serve as the host for that view? So that's where self is passed. And then the last parameter in the init view is the container, the parent control. Who's going to hold the instance of this view? Well, it's my startup tab in this example. And then we can go through for all the rest of them, and then the creating of the current form view is just referencing the view for startup. That's what I'm working with, and then I actually call the notification for the current view. Say enter startup right at the beginning. So I could do some setup if I wanted. What this does is it sets the right graphic for the load screen and so forth. Change view, this is it. Yours would change subtly, but the general role that it's doing is the same. It's whenever we change a view from one to the other, we need to tell we're leaving the old view, tell we're going to go into the new view, so let each view become aware that that's happening, update the current form view, and then actually do the navigation. And so again, we're using the tab control. To do the sliding, the animation, you have to use a tab action. That's how that works. So that's what these two steps are doing is I'm setting the new tab to be the tab control that serves as the parent control for the current view. So this is what I want to move to. It knows what tab control that is, and then tell the tab action to go change to it. It knows, based on the order of the tabs in the tab control, which way to slide. So if I'm going to a tab that's further on the right, it slides everything to the left. Likewise, if I say, oh, I want to go back to the other one, then it slides the other way to do that. So we don't have to think about any of those things. So we've done that setup on the host. Now we have to build our views. Our settings view or the roster view. What do we need to do for there? Well, it's actually quite simple. We simply change the ancestor of the form to be, instead of T-form, it goes to T-form view, which we've already defined. That means we have to add some implementations. Specifically, we don't have to do anything because T-base form view, which is what T-form view descends from, has a basic implementation. Generally, though, we're going to probably want to do things based on that view. So when our view gets created, we may want to lay out things different, dynamically, for example. Likewise, when we enter and leave, we would override those. The key thing that what the init view gets overridden specifically to do the connection between that layout that I've designed everything in to the parent control that's going to host it. So this is the key thing. This is where I'm changing that layout contents parent to be not myself, not the form, but to be the tab control or wherever it needs to be. And I like doing this instead of changing the form itself because the form, although a component, has different baggage and side effects that happen, whereas a layout is just a container. And so by reparenting the layout, everything goes with, my form is still sitting over there, just no one sees it. It's the controls are parented in the tab control. And so it works really well in doing that. All right, so just to give context, we just got a couple more minutes, and we'll take some questions. I wanted to highlight a couple things in looking at the code a little bit more. So going to the main form here, and go back to the code, and if we go up to the top, to the way top, there's a number of controls, but here is where our host is descending from iViewHost. So everything is there. So of course we're going to have implementations of iViewHost, those methods. This is the app-specific ones, and then the base ones that I've created. So just contextually, that's where you would need. The populate views and change views are there. That's what I showed in the screens. That is the literal code that was from here, is where that happens. And so when things, the rest of the code is simply to invoke the REST services. So you guys can take a look at that on your own. From the creation of, when we go into here, this is all basic. The populate views, we do need to call that. So call that in the form create to populate the views. That sets up all the different tabs with us. And then you'll typically want to change to the first tab. And so we would set that up. Populate views is all there, and the change views. So nothing real special that's going on in any of those. If we take a look at each of the forms, so I designed the form first as how I want the view to be. Nothing different. It's just a regular form. I laid out all the controls, set them up, and then when I'm ready, I go in and change from T-form to T-form view. And that was start of it. Then I overrode these three methods. And this is the only thing that is different in these. And so here's where I'm setting that up. Oh, and I actually grabbed the embedded search box only because this is just special with the list control that's in the FMX in order to do stuff. I want to know is if I'm typing something in, I can trigger that and do something with that. So that was just kind of a helper. So all the other forms are done the same way. So if I go to what's nice, so it's the hitting stats is a form view. got a bunch of controls on it, but that's just controls. The actual code is there's nothing that's real fancy. The same thing for the init view, reparents the controls. When I enter the control, I call update stats. Well, update stats is something local, so let me navigate to update stats, which is down further in the file, and this is taking the view host's app data. So here's how I can get back to the host. The host has the data, has the connections, everything that it needs. My view is saying, hey, host, give me the player stats for this current player, and because that's what's the current player. Well, that was from the roster view when I clicked on it. So when I clicked on a player, I told the view host, hey, the current player is now, Albert or Morris or whoever, was. And so that gets recorded. Now I have that in any subsequent views. So I know there was a lot there, didn't have a ton of time. Does anyone have any questions on this approach for handling view management inside of FMX? And if it does, oh yes.
Because you still have empty tabs in the main form, I wonder, can you actually create them by code? Because it seems like at this point in populating, you kind of have all the information you need to actually generate them by code.
Yes, the question was, I still have empty tabs in that tab control. I created tabs for each of the views that don't have anything in them. They do right at the form create. So the question was, could you create the tabs dynamically? Absolutely. I'm going to take that question and take it even a little bit further, because one of the things that comes up is, well, what if I have a lot of views in my application? Do I have to create them all at the startup? That might take a while. And the answer is, well, no, you don't. You can dynamically create your array that holds the views would be fully fleshed out, because it would have entries for each enum value that you create, but they don't have to have a reference to the view until you do something that needs to go to the view. So taking that further, you can load on demand and throw away on demand if you really had resource-intensive views. So you have a lot of flexibility that you can go with that. Any other questions? Yes?
Could you show the code after the app data dot when you load the player? Okay.
Oh,
the first line in this method, the first line players, view host, app data, active player.
yes.
Could you show the code after behind? Okay.
So active player is a property that goes to get active player, which takes the active player's ID and finds it in the roster that's been stored, and either returns a valid value or nil if it doesn't exist. Now, where that's set, and maybe that's what the question is, on the roster, when I have the roster, this is a list view, and if I go that there's an item click, so if I double click in there, I call select player, and if you remember, this was one of those app-specific view host things that we implemented. So this is where that connection is made. And again, it's a great question, because it's, as you start thinking about this, this was how the view just does the view things. But it's going to need data for the rest of your app. Well, we get it through the host. We always go to the host to get it down. No worries. Great question. We got like a minute and a half before I can let you guys go. Any other questions, comments on any of this? Yeah, generic interfaces was, once I kind of got my head around it, then the challenge was like, oh, I get it. Now I have to explain it to people. So that's what this session is trying to do, and I hope it made sense. Ooh, I love the little conversations that are happening across the room. This is what makes a conference so powerful, is to get everyone thinking about different ways of solving a problem. That's all this is doing. And if you're welcome to leverage it, like I said, the code is in the download materials, and take it a little further, what you want to do. I have leveraged this in apps, so I mean it's been working quite well. So if there's no more questions or, Danielle.
Great. One of you needs to show another view. Maybe a list, pick one and just show them. It is the view which asks to the other view to show, or view asks to the view host to show this other view.
If you didn't hear the question, it was if I am going from one view to another view, and maybe drilling down, who's responsible for getting the other view to take ownership? And is it the view that I'm on telling the next view, oh, you're now active, or is it going redirected through the host? It's going through the host. It always goes through all the navigation. The view says, hey, my state has changed. You may want to do something with that.
And maybe also the host state changed.
Correct. The state change could be done either way. You know, the host might prompt the change or the view itself. The key is that the switching of the views really should not be done by the view itself. It's just representing the data at this point in my application. But thank you so much. I hope you enjoy the rest of the conference.